In this video, I'll show you how to solve the ALEKS problem called balancing chemical equations with interfering coefficients. Interfering coefficients meaning that the stoichiometric coefficients are going to interfere with each other, or in English, this just means this equation is going to be kind of tricky to balance. I'm going to start by copying the equation down into this space here just so that I have a little bit more room to work with. I don't need to be copying down the states, the liquid, the gas, the solid, etc., because that's not used when we're balancing the equation. When I'm balancing an equation that has interfering coefficients, if I know that the equation is going to be a little bit tricky to balance, then I'm always going to use my trick of making a list of all of the atoms that are on the left-hand side and then also writing that list over on the right-hand side. I want to do this so that my atoms are in the same order in both lists. It makes it a lot easier to keep track of. And I'm going to start by filling in how many atoms I have to begin with on the left-hand side. That little 4 after the SI tells me that I have 4 Si atoms, the 10 tells me I have 10 hydrogens, and the 2 is for 2 oxygen atoms. Over on the right hand side, I have 1 Si atom, I have 2 hydrogen atoms, and then you got to be a little careful with the oxygen. It's in 2 spots. We have 1, 2, 3 total oxygen atoms. So I'm just going to start at the top of the list and work my way down, starting with the Si. I have 4 on the left. I only have 1 on the right. I need 4 on the right. I'm going to put a big 4 in front of this molecule. 4 times 1 is 4, so now I have a total of 4 Si on the right-hand side. That has also changed the number of oxygen atoms because oxygen is in this formula as well. So now in terms of oxygen, I have 4 times 2, which is 8, plus 1 more, which is 9. Next, I'm going to balance my hydrogen atoms. I have 10 on the left and only 2 on the right, which means I need to have 10 on the right-hand side as well. So I need to come up with a number that I can put here that's going to give me 10 hydrogen atoms. Basically, I'm saying what times 2 is going to be equal 10, and you guys probably know that that's a 5. So 5 times 2 means that I have 10 hydrogen atoms. And again, I have also changed the number of oxygens because I have oxygen in this molecule as well. So now I have 4 times 2 is 8 oxygen plus 5 times 1. That gives me 13 oxygen atoms. So my silicons are still balanced, my hydrogens are still balanced. Now I have to balance the oxygen, and this is where the interfering coefficient part comes in. I have 2 oxygen on the left and I have 13 on the right, which means that I need 13 over here on the right. But here's our problem. Oxygen comes in the form of O2. So the question here is what number times 2 is going to equal 13? There is no whole number or integer that we can multiply by 2 and come up with an odd number of 13. It's just not possible. So what do we do in a situation like this? First of all, stay calm, don't panic. When you have a situation like this, we call this interfering. The easiest way to solve this is to pause and double everything that you have right now. Just go through and double everything. So what I'm going to do is say this is no longer going to be a 1, it is now going to be a 2. Now, when I say I'm going to double, well, we can double everything. This oxygen is no longer a 1, it's now a 2. My 4 is now an 8. And my 5, I've doubled, it's now a 10. And remember, you also have to double down here. 4 is an 8, 10 becomes 20, 2 becomes 4, this 4 becomes 8, 10 becomes 20, and 13 is now a 26. So I've just doubled everything. By doubling everything, I no longer have an odd number of oxygen atoms, so there isn't the interfering situation anymore. I have a total of 26 oxygen atoms on the left, and that means I need a total of 26 oxygen atoms on the right. What number times 2 is going to equal 26? It is 13. So instead of having 2 here, I want to have 13. 13 times 2 is a 26.